So welcome to this video on binomial expansion. I want to take you through a question here which reads 1 minus 3 over 10x to the power of 5. You're told to expand that, and then you use the same expansion in part A to actually estimate the value of 0.97 to the power of 5. Okay, so up to this point, I know you know how to extract the binomial coefficient, but maybe before I solve this, I should also show you how to use a calculator to actually extract the binomial expansion. The other technique which is also used to extract those coefficients, I may do it at the end of this video, but for now let me show you how to use them. If you don't use your mathematical figure, how then can you use your calculator? So you can say, if you want, let's say, the first coefficient, so let me write here the coefficients we need. So we want to have the coefficients of something to the power of 5. So you start by keying in 5, then you go to the button here, which is NCR, that means N choose R, you key that, and then you have 0. It gives you the first number. You write there. Then you do the same thing. Now this time you key in 5, choose 1. Remember, you must always begin with a 0. So you have a 5. Then you go to 5, choose 2. You have a 10. Actually, if you're familiar with these coefficients, you can see that they are now matching. 5, choose 3. You have a 10. Then you're almost there. 5, choose 4. You have a 5. And finally, you choose 5. So you have 1. So we have our coefficients. Well done. So we have our coefficients as 1, 5, 10, 10, 5, 1. So the same coefficients can be extracted from our 4 figures or our mathematical tables, or you can use another technique that I will show you towards the end of this video. So let's focus on our question now. When you're given a question like this, it is always very important to understand that if you're expanding something of this form, then you should know that this first number here, the first term, is to the power of 5. The second term is to the power of 4. The third one is to the power of 3, power of 2 in a decreasing manner up to the power of 0. Then where you have this, the other one begin with the highest power, decreasing as you move from right to left. So any number raised to power of 0, you know it's a 1. So we can write this one as a to the power of 5. And then notice that when you have a minus sign here, and I want to point out this one very clearly, when you have a minus sign and the power is odd, the sign you begin with here is a minus. So I have a minus, I have a plus, I have a minus, I have plus, and I have a minus here. So those are the signs we are going to have, and you can see they alternate from minus, positive, minus, positive, minus. I know you are asking me what would happen if the sign is minus here and the power is even. Again, when you have such a scenario, you start with a positive sign here. When the power is odd, but the sign is positive, so everything is a positive. But when the power is even and the sign is minus, then you start with a plus, minus, plus, minus, plus. I should come again. When you have a minus sign but the power is even, you start with positive, negative, positive, negative, in such order. All right. So let's simplify this one now, introducing our coefficients. So we know we have a to the power of 5 minus 5 a to the power of 4b plus 10 a to the power of 3 b squared, and then minus 10 a squared b cubed, and then we have so we have minus plus minus plus 5ab fourth, then finally we have a to the power 0 is a 1, so we have b to the power of 5. Now, what is our a and what is our b? Going back to what we were given earlier on, 1 corresponds to our a here, and b corresponds to 3 out of 10x. So we can substitute that very quickly. So we have 1 minus, so 1 to the power of any number is just a 1. So that one I will not raise to the power of anything because I know the answer is the same. So 5, 3 over 10x, right? Then plus 10, a 1 is not must I write a 1, so we can continue. So we have 10, then 3 out of 10 x to the power of 2 minus 10, 3 out of 10 x to the power of 3 plus 5, 3 out of 10 x to the power of 4, and finally 3 out of 10 x to the power of 5, right? So if that is what we are having, then we can simplify this one very quickly to this. So we have 1 minus 3 out of 2x, you cancel that, plus 9 out of 10x squared. If you multiply here and you distribute, you have minus 27 out of 100x to the power of 3. Then you have plus 81 x to the power of 4 over 2000. Let's confirm that, because we have 3 to the power of 4, that is that, times 5, divide by, we have 10 raised to the power of 4. I guess we should have something of the sort, that is 81 out of 2000, so I'm there. Then finally you have minus 243x to the 5th. Then when you raise that to the power of 5, you're going to have 100,000. So that is our expansion. Then we use that expansion to actually solve this one. And to solve that, we usually take 1 minus 3 out of 10 power of 5, and we equate to whatever we are going to estimate. And because the powers are the same, we equate what we have in the parentheses. It goes without saying that x is 0.1, because by taking 0.1 here and multiplying, you're going to get 0.97. Maybe 3 over 10 times 0.1, you get that 1 minus answer is 0.97, right? So I think the value of x is okay. So when you estimate, you have this 1 minus 3 out of 2 from our expansion here of 0.1, then plus 9 out of 10, should be 10, 0.1 square, then you put parentheses, minus 27 over 100, 0.1 cubed, plus 81 over 2000, 0.1 the power of 4, and finally 243 over, is a minus sign here, running out of space, 10,000, 100,000, then 0.1 to the 5th. When you simplify that, you are going to have 1 minus 0.15 plus 0.009 up to a point when you are going to add and you get 0.859, and that's the answer. So I want you to look at this aspect here. When you do not have the coefficients, how else can you extract them? This is how I want to show you. So we use what we call the combinations. So n, choose R, it's here. So n choose R stands for n factorial over n minus R factorial R factorial. So this n here, we take its factorial, then we subtract this R here, then we take its factorial, then R factorial. This is what we call combination. Combination. For example, we will need the coefficients as follows. So 5 choose 0, we will need 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, need 5 choose 5. Alright, so all these answers will give us now the binomial coefficients. Now quickly, so we take 5 factorial over 5 minus 0 factorial, 0 factorial. So 0 factorial is a 1, so 5 minus that factorial, you get a 1 quickly. Then 5 factorial over 5 minus 1 factorial, 1 factorial will give us 5 factorial over 4 factorial times 1 factorial is a 1. So this one can be decreased in that form, 5 times 4 factorial over 4 factorial, giving us just a 5. So that checks. Then 5 factorial over 5 minus 2 factorial, 2 factorial. So you have 5 factorial over 3 factorial, 2 factorial. 2 factorial is 2. So you have 5 factorial times times 4 times 3 factorial over 3 factorial times 2 factorial. So this cancels with that, we have a 2, that cancels with that, and we are left with a 10. That checks. Now 5 choose 3, we have 5 factorial over 5 minus 3 factorial. Then we have 3 factorial. So this gives me 5 factorial over 2 factorial and then 3 factorial. So this gives me 5. We are taking 5 minus 3, so we have 2 factorial and then 3 factorial. So 5 factorial times 5 times 4 times times 3 factorial over 2 factorial times 3 factorial, that cancels with that, and you are left with this times that divided by that, you have a 10. Again, finally, so we are almost there. We are now doing this one down here. 5 factorial over 5 minus 4 factorial, then 4 factorial. That gives me 5 times 4 factorial over 1 factorial, 4 factorial. That gives me a 5. You can see that these coefficients now are almost, not almost, they are matching what we usually have as our coefficients. So we take finally 5 factorial over 5 minus 5 factorial, 5 factorial. So this one gives me 5 factorial over 0 factorial, 5 factorial. I said 0 factorial is a 1, and so 5 factorial over 5 factorial is a 1. So these are the coefficients we saw earlier on as 1, 5, 10, 10, 5, 1. I'm sorry I did it in a hurry here because of the concept of time, but these are the coefficients we get using the combination formula. Thank you.